आज का जो टॉपिक है वो पोल्यूशन को कंट्रोल करने के हवाले से या पोल्यूशन को रिड्यूस करना कैसे हम कर सकते हैं। कंट्रोल मेजर्स टू रिड्यूस पोल्यूशन, कंट्रोल ऑन मेजर pollutants, control on sulfur and nitrogen oxides emissions, smoke reduction, removing SO2 from coal exhaust, controlling nitrogen oxide emissions, control of particulate matter, control measures to reduce air pollution. Solution efforts on pollution always a big problem. This is why prevention interventions are always a better way of controlling air pollution. These prevention methods can either come from government laws or by individual actions. In many big cities, monitoring equipments have been installed at many points in the city. Authorities read them regularly to check the quality of air. Government or community level prevention. Governments throughout the world have already taken action against air pollution by introducing green energy. Some governments are investing in wind energy and solar energy as well as other renewable energy to minimize burning of fossil fuels which cause heavy air pollution. Governments are also forcing companies to be more responsible with their manufacturing activities so that even though they still cause pollution, they are a lot controlled. Companies are also building more energy efficient cars which pollute less than before. Individual level prevention. Encourage your family to use the bus, train or bike when commuting. If we all do this, there will be fewer cars on road and less fumes. Use energy, light, water, boiler, kettle and fireworks and firewoods wisely. This is because lots of fossil fuels are burned to generate electricity. And so if we can cut down the use, we will also cut down the amount of pollution we create. Recycle and reuse things. This will minimize the dependence of reducing new things. Remember, manufacturing industries create a lot of pollution. So if we can reuse things like shopping, plastic bags, clothing, paper and bottles, it can help. Control on major pollutants. Control of sulfur and nitrogen oxide emissions. Several steps could be taken to prevent sulfur and nitrogen oxides emissions. Burning low sulfur nitrogen coal and fuel. Removing sulfur nitrogen from coal and fuel by fluidized bed combustion. Removing sulfur during limestone injection and multiple burning of powdered coal and fuel. Improving energy efficiency and shifting to less pollution fuel, especially solar produced hydrogen gas. Removing carbon dioxide from coal exhaust. In order to reduce sulfur dioxide emissions from air, we need to remove sulfur dioxide from coal exhaust during combustion. This can be done by fluidized bed combustion in which granulated coal is burned in close proximity to calcium carbonate. The heated calcium carbonate absorbs sulfur dioxide and produces calcium sulfate, which can be used in the production of gypsum wallboard, also known as sheet rock for houses. Some of the sulfur oxide that does escape the combustion process can be captured by other methods after combustion. Smoke reduction. Since ground level ozone is formed by photochemical reaction of nitrogen oxides and certain hydrocarbons, strategies should focus not only on reduction of emissions of these substances but also on their ratio and balance. In areas where NOx concentration are high relative to WOX, the abatement of VOC emissions can reduce the formation of ground level ozone, which reduction in nitrogen oxide may actually increase it. In areas where the relative concentration of WOX is high compared with nitrogen oxides, ground level ozone formation is NOx limited and NOx reduction work better than VOC abatement reduction. Controlling nitrogen oxide. There are two methods to control nitrogen oxides emissions: burning fuel at lower temperatures, catalytic converters for automobile exhaust. Hotter burning conditions and presence of oxygen allow proportionally more nitrogen oxide to be generated per unit of fuel burned. In order to reduce nitrogen-oxygen emissions, burn temperatures must be reduced and the amount of oxygen must be controlled, a procedure that is sometimes utilized in factories and power plants with certain air pollution control technology. Catalytic converter. Nitrogen oxide emissions from automobiles have also been reduced significantly. All new automobiles in the developed countries were required to include a catalytic converter which reduced the nitrogen oxides and carbon monoxide emissions. In order to operate properly, the precious metal in the catalytic converter, mostly platinum and palladium, could not be exposed to lead. This in turn means that gasoline could no longer contain lead. Lead in gasoline was a major source of atmospheric lead and a hazard to human health. At the same time, improvements in the combustion technology of power plants and factories reduced emissions of nitrogen oxides from those sources. Working of catalytic converter. Dirty exhaust from engine catalyzed on honeycomb structure. Control of particular matter. Control of particulate matter. The removal of particulate matter is the most common means of pollution control. Number 1, gravitational settling. The simplest removal method is gravitational setting, which relies on gravity to remove some of the particles as the exhaust travels through the smokestack. Landfill. Ash residue that accumulates must be disposed of in a landfill depending on the fuel that was burned. The ash may contain sufficiently high concentration of the metals that require special disposal. Gravitational settling chamber, used to remove particles with size greater than 50 micrometer. Velocity of flue gas reduced in large chamber. Particles settle under gravitational force. Installation of pollution control devices. We need to install pollution control devices that can remove particulate matter and other compounds after combustion. Each has its advantages and disadvantages, and all of them use energy, most commonly electricity, and as a result generate additional pollution. Baghouse filters. Fabric filter shown in the figure. These are a type of filtration device that allows gases to pass through them but remove particulate matter, often called baghouse filters. Certain fabric filters can remove almost 100% of the particulate matter emission. The baghouse filter in this air pollution pollution control device, particles are removed by a series of filter bags that physically filter out the particles. Electrostatic precipitators. In these devices, use an electrical chain to make particles so that can be removed. Polluted air enters the precipitator and the electrically charged particles within are attracted to negative or positive charges on the sides of the precipitator. The particles collect and relatively clean gas exits the precipitator. Dirty gas enters precipitator unit. Particles in the combustion exhaust stream pass by negatively charged particles, which gives them a negative charge. The negatively charged particles are attracted to positively charged collection plates. Cleaned air moves out of the unit. The positive collection plates are periodically discharged, which causes the particles to fall off so that they can be removed from system. The electrostatic precipitator in this air pollution control device, particles are given a negative charge. This causes them to be attracted to positively charged part plate where they are held. Periodically, they are removed from the plate and collectively for disposal. Scrubber. A scrubber uses the combination of water and air that usually separates and removes particles. Particles are removed in the scrubber in a liquid or sludge form and clean gas exists. Borrowing from the concept utilized in the electrostatic precipitator, particles are sometimes ionized before entering the scrubber to increase its efficiency. Scrubbers are also used to reduce the emissions of sulfur dioxide. All three types of pollution control devices, because they use additional energy and increase resistance to airflow in the factory and power plant, require the use of more fuel and result in increased carbon